Okay, so how about if we start, as we usually do, um, with a quick review of the problem and the mission. Maybe one of you can share your screen and show your lab book. And let's practice presenting the chain reaction machine from your lab book. One of the exercises we want to start doing today is to write a storyline about your project so that we can take a video of your project and put it in the Hall of Fame. So, Sophia, Montserrat, who'd like to share their lab book?
Montserrat?
Come on, Montserrat, I know your lab book is way cool. Do you remember how to share your screen and how to call up your lab book?
Yes.
Okay, good. All right, Montserrat, you come a long ways. I can tell you know how to, you're the master of your computer. You tell your computer what to do rather than the computer tells you what to do. That's a good state to be in.
Where is no? Where is?
Try go to Archivo and open Archivo.
Maybe in PowerPoint.
And abrir recientes. Open recent.
Oh, yes, I remember.
There we go. Do you see your lab book? There it is.
Problem. For doing activities.
Hold on a second. It hasn't come up yet. Okay, right now. Good. We've got it. Okay, go ahead, Montserrat.
Problem. For doing activities, you need to have teamwork. For some people, it's difficult to do teamwork. Mission. Build a machine demonstrates teamwork. That demonstrates teamwork.
Excellent.
That people work together and make machines.
Okay, very good, Montserrat. That's clear and concise.
John, we're seeing this in the class.
Oh, really? You're studying this in school already?
Yes.
Okay.
Yes.
Well, then you're way ahead of the class. Can you explain this slide, Montserrat? The slide on simple machines?
The lever, it's how I can explain to you. Sophia, how do you say the balance scale?
Like a balance scale or something like that?
The balance scale and the wheel and the wheel and the axle for a bicycle.
Good.
And screw like this over the bottom.
Yep, that's a screw. Very good example. Excellent example.
The pulley elevator and the
allows you to lift heavy objects.
The plane. This one.
Yes, inclined plane.
It's what?
Stairs?
Yes. When
The stairs is a form of an inclined plane. That's true.
yes, and the wedge, some scissors or a hammer.
Yes, or an axe or a knife even.
A knife. I'm sorry. I'm crazy.
Okay, next slide. Very good. Very good, Montserrat.
The catapult.
What are the factors that control a catapult? A catapult is one of the links in our chain reaction machine. So it's important to know how a catapult works.
Where's my catapult? Oh, there's. And
Okay.
you put a ball and you jalar. No. Pull. You
Yeah.
pull
You pull the arm so it moves quickly.
the
Counterweight.
Yes, and the rock goes far away.
Okay, good.
And teamwork.
And your graffiti that you're gonna print and mount on signs to put on your chain reaction machine, so everyone will know what your chain reaction machine is about. Terrific. Nicely done, Montserrat.
Actually, I haven't finished, but.
Okay, well, you can put that on your to-do list to finish your name.
Hi, Alfredo.
Hi, Alfredo.
Okay, Alfredo, welcome. Good to see you. Okay, so the mission for today is to build another link for our chain reaction machine, and it's a link that you can use your own imagination. Instead of following our instructions, we're going to look at some examples, and maybe one of these examples will inspire you to make a link that will make a noise.
Yeah.
We have, Alfredo, can you describe all the members of our machine, the team members of our machine? What's the first member of the machine?
The
One that starts it? The coin spillway, right?
Yes.
And then, Sophia, what's the second link on our machine team? After the coin goes down the spillway, what's the next team member that has to work?
I don't remember how to say. It's like a ramp or something like that.
It's like a seesaw.
Yeah.
A seesaw, okay. And
Yeah.
that's called the coin trigger, the golf ball trigger. Okay, and then after the golf ball is released, then what's the next member of the team that has to work? Montserrat, after the coin goes down the spillway and hits the seesaw, or drops in the seesaw and releases the golf ball, then what does the golf ball do?
Oh.
It rolls, exactly. It rolls down the table through a series of bumpers. Right? So that's the third member of the team that has to work. All members of those team have to synchronize and work together, otherwise the machine fails. Okay, so we have a coin sensor, then the golf ball trigger, then the ramp that the golf balls go down, and then what's the next link in the machine, Alfredo?
The catapult.
A catapult, excellent.
And then this week I have doing a chain reaction machine.
You're building a new chain reaction machine?
Yeah, I have the video here.
Okay. Do you want to show us?
Yes.
Okay. Montserrat, can you stop sharing your screen? Keep going on your graffiti. It looks great. It looks great, Montserrat, what you're doing. Okay, Alfredo, take it away.
It's this.
Oh, no way, that's you.
Yeah.
Who's that handsome guy? Okay, let's see how it works.
Handsome.
Oh, no way. I love it. Oh, Alfredo, spectacular. Way to go. Where did you get those inspirations?
From the
videos.
past chain reaction machine that we did.
that we looked at from previous machines we built and from Googling chain reaction machines. Can you show that video once more? And let's see how that house of cards is stacked up, okay? Nice. Oh.
Alfredo, I have that letter too.
Okay, cool. I see how you built that house of cards. That's very nice, very sweet. Okay, and the dominoes, they make a nice noise. So that's a good part of your machine. Okay, nicely done, Alfredo. Thank you for showing that to us.
Yes.
Okay, Sophia, I know you were traveling last week, so you probably didn't get time to do much, but let me show you, I'm going to share my screen and I'm going to show you one of the videos that we looked at last week. And let's see if we can build something like this, or this will inspire us to build a new link with your own imagination. Okay, so let's go to here.
Like the
same machine we looked at last week, but a couple of things I want to point your attention to.
I love that because it looks so cool.
It is cool. Okay, this is a little overwhelming. There's a lot of hours that went into this. But notice how they have so many golf balls on ramps ready to roll. I think it would be interesting to try this, to have 2 golf balls. And the first golf ball is going to get released by the coin sensor, and then the second golf ball will roll down a whole nother spillway after it's released by the first, okay? So I'm going to stop this when we get to a golf ball mechanism that I think will work better. There's what Alfredo did. That's like the ramp we built. Oh, look. Oops. Okay, so what we want to do is see a golf ball is resting on a ramp, just like we can build that ramp easily. And how does that golf ball get released? There's one release, something pushes it. There's another golf ball right here in the middle with a string holding it. And when the string is pulled, then the golf ball rolls down. Okay, that's probably the easiest one to do. Let's see if I can back that up just a second. Okay. Oh, that's a nice one. The marble rolls in the bottle. Makes a nice sound. And that's another one with a string. When you pull the string, the string is what's holding the golf ball on the ramp. Okay. Lots of inspirations here to make your own. Okay, I'm going to stop this again. And let me just stop sharing. I'm going to show you my video now. So hold on a second. Let me stop sharing this. Okay. And you remember we made bumpers that looked like this, right? We made it 1 inch or roughly maybe 2 centimeters on each side. We made a mark like this. We cut them out and then we scored right down the middle with a pencil or a scissors so that it folded nice and sharp, right? So what we're gonna do is put 2 of these together. We take 2 of these ramps that we built or bumpers that we built, and look, if you put them together, then you get a spillway for a ball, just like the one we were looking at, right? So your golf ball could roll down that spillway. And then with that, when we have that spillway, we could build a vertical element, 2 vertical elements, and we could take that spillway just like we did with the coin sensor. Remember the coin sensor, the coin sensor can roll down this, right? Just the V. That's really easy for the coin to go. A little harder for the ball to go down that. So if we do this, then it allows us to let the ball roll down nicely. Okay? So if we could build something like this and then mount it vertically, just like we did with the coin sensor, then we can put a golf ball up high, and that gives us more energy. So we can, when the golf ball is rolling down on the table and we want to generate some more energy, we can use the golf ball, the potential energy of the golf ball that's resting on a higher ramp. And when we release that, then the golf ball can roll down and you have a whole bunch of new energy to work with. So we're basically, in this chain reaction machine, converting potential energy to kinetic energy. Potential energy is the ball sitting up high, and then kinetic energy is when the ball starts rolling. Make sense?
Yes.
Okay, so your mission next week, for next week, is to build a spillway for the ball, and then we'll figure out when your ball is rolling after it's been released by the coin sensor and the seesaw, the ball will roll down the bumpers on the table, and then it will hit something that will pull a string, and when that string is pulled, it'll release the ball on the higher ramp. Is that a challenge you can all follow? I'll send you an email that gives you some hints on how to build that.
I don't know. I'm not sure.
Okay, I bet you when you get the email, Montserrat, it'll be very clear how you could build that. Okay, and then what we want to do is we want to make an interesting sound. So when that golf ball rolls off the ramp, it would be nice if it could drop in a bottle or a tin can and make an interesting sound, or maybe even hit a bell. Okay? And then once we have that link to the chain reaction machine, that'll be our last link. And then we're going to write a storyline. In fact, we're going to start today to write that storyline, and then we'll present. We'll make a video to present your teamwork chain reaction machine. Everyone on board with that?
Yes.
Okay. So there's 2 things we want to do on our lab book today, guys. The first one is we're going to document the advantages of modular construction. So let me just follow this. Oh, am I sharing my screen? I guess not. Hold on a second. Let me share my screen again.
Yeah.
Okay, can you see this PowerPoint?
Yes.
Yes.
Good. Okay. This is a really useful trick when you're building, guys, to build with modular construction. We've been practicing this all along, but we just want to document this page in your lab book. And here's the logic behind it. So if you looked at this invention, it's a wizard that when you put a coin in its mouth, it will shake its head yes or no to answer a question. So you can say, wizard, wizard, am I good looking? And you put a coin in the wizard's mouth, and the wizard will shake its head yes or no.
So if the wizard says no, oh my gosh, I don't look good.
That's right.
I'm gonna dress up again.
That's right, exactly, Montserrat. So this is a famous wizard that answers your questions. And if you look at this wizard, it looks really complicated. How would I ever build something like that? However, if you look at it carefully, it's actually made up of 5 very simple modules. So modular construction is all about breaking a complicated machine into really simple parts. And the first module is a gear train. The second module is a simple coin detector. The third module is a ramp. The fourth module is a second gear train. So we have 2 modules here that are exactly the same. They're just, one is controlling the head to shake its head no, and the other is controlling the head to shake its head yes. And then we have a fifth module that is a chassis module where the whole head rotates back and forth to the right and to the left. So it looks complicated altogether, but when you break it down into its simple parts, it's really just made of simple modules that look like this. Okay, so a big challenge when you're building a complicated machine is to break it down into simple parts. Here's another example. When we're building a character, what we want to do is break the character down into simple parts, build the hands and then put them aside. Build the hair and then put them aside. Build the eyes and then put it aside. Then build the nose and so forth. So these are all the modules. And when you put all these modules together, then you get a finished critter. That make sense?
Yes.
Break your problem, break your solution into its simplest parts. Who of you plays an instrument? Does anyone play the piano or the guitar?
No.
No? Okay, well.
Oh, yes.
You studied piano, Montserrat?
No, I don't say it.
Oh, Sophia has.
No, it was Alfredo.
Oh, Alfredo, you're a musician. What kind of what kind of instrument do you play?
Guitar?
Guitar, cool.
Yeah,
I like to play the guitar.
ukulele. You know what it's it?
What's that instrument?
Ukulele?
Oh, ukulele, the guitar and the ukulele, cool, I love them. But when you play those instruments, very often you'll play what's called a riff of music. It's several bars of music that you can use again and again and again. And that's basically modular construction. In music, you see modular construction often. You'll get a series of bars, 3 or 4, 2 or 3 or 4 bars that sound well together. And then you can reuse those bars once you've mastered them. You can reuse them in all kinds of creative solutions or compositions. When you're doing scratch programming, you can write your code in simple modules like this, blocks of code, or you can do it the ugly way and make a big rat's nest or a long string of code that's much more difficult to edit and understand. So basically, we want you to think about how you can simplify your solution by breaking it down into very, very simple parts. So what if we take 10 minutes in your PowerPoint lab book, open up your PowerPoint lab book, and let's start a new slide that says modular construction.
John,
Yes?
I cannot enter to PowerPoint without sharing my screen.
Okay, I can help you. Montserrat, your question was, you can't enter while you're sharing your screen. I see. Right. Okay. Good point. So let's see. The way to solve that is I'm gonna put this in the chat box. So you can go into the chat box and you see how this looks, right?
Yes.
Okay. So I'll put all of this text in the chat box. Okay, Control C. And then, so open up PowerPoint Lab Book. And I'll as soon as I stop sharing my screen, I'll, okay. So you want to build quickly. Oh.
How's the title, Jan?
Make reliable.
Jan,
Yes.
what's the title for the...
Modular construction.
Thanks.
Okay. Modular construction. You're going to see it in the chat box in just a second.
I cannot go.
Make reliable. Edit quickly. Okay.
John, I can do it. Isolation.
You can put your screens, you can put one screen on one side of one window on one side of your screen and another window on another side of your screen. That's the easiest way to do it.
I just do it.
Okay. Good. But if you can also look in the chat box and you'll see, and the title should be okay. And I'll go back and share my screen. So if you set up your windows so that the PowerPoint window is on one side and you're sharing your screen on the other side, then you can see. Okay. This is, I find, one of the most useful building tricks, especially when you're building complicated machines like we're building. Think about how you can break it into simple parts. Then you can change your solutions easily, change your edit easily. You'll make your machine much more reliable because those simple modules are reusable, so you know that they work. And it also dramatically simplifies your solution when you break it into simple modules.
What we need to make in PowerPoint?
You want to add this slide to your PowerPoint. Right.
What slide?
This slide right here.
Oh.
Oh, the ones over there?
Yep. Modular construction, build quickly, change solutions easily, make reliable, and simplify.
I cannot go now. Okay, there's.
You know how to insert a new page in your lab book, right?
Yes.
Okay, and make it a blank page so you can control the layout.
Yes.
And then add word art for modular construction.
Yes.
And then add a text box that says build quickly, change or edit solutions easily, make it reliable, and simplify. Those are the 4 advantages of modular construction. Okay, we'll work on this for another 2 or 3 minutes, and then I'll send you an email with the second part of the email is going to be this slide, so you can, if you don't finish it now, you can finish it later. But when we present our project, this is a slide we want to explain. This is a key trick to building our teamwork machine and making it reliable. Work 9 times out of 10. Who's almost done?
Me.
Yeah? Okay, good, Alfredo.
Almost.
Okay.
John,
Mm-hmm.
I have a question.
Sure.
The machine that we're gonna build by ourselves, we have to
A link to the machine, the module that you're going to build yourself, yes?
we have to put the machines that you show us how to do it.
Yes, I'm going to send you a picture of an example, but you want to make it your own. You want to make it even better than what I'm going to show you.
Look, it's because I have an idea for that.
Great. If you have an idea like Alfredo really went to the extreme to build a whole slew of new links.
I like to do a machine or
Yeah?
line with balls.
Okay. All right. 30 more seconds, guys, and then we'll stop and we'll add a new page in your lab book. And this is going to be the start of the storyline for the video that you're going to create. Okay, we all set?
No.
Yes. No.
Okay, Montserrat, you can finish this later on, all right? So we have another 10 minutes or so before we adjourn. So let's get the second slide started, and then you'll have some challenges for next week, some projects to work on if you have time after homework to finish for next week. So the next thing we're going to do is write a poem, a story about our teamwork machine. Okay, so I'm going to insert a new slide. a blank slide. And we're gonna insert word art here.
Wait,
And we're gonna call this our teamwork. Okay, and then we're gonna put this at the top of the page, our teamwork machine. So let's do this. Let's try to write a poem about our teamwork machine. Has anyone written a poem before?
yes.
Me.
Yeah? How do you go about writing a poem? What's the strategy for writing a poem? Well, one way to do it is to write a couple of words that are relevant to what you want to say, and then you think of words that rhyme with those words, right? With those key words. So let's document teamwork. Whoops, teamwork. Let me just. Sorry, guys. I'm gonna make a text box here. Teamwork. What rhymes with teamwork? What's a word that rhymes with teamwork? Teamwork. How about work? Perk. Work. Turk. Bark. Bark. Teamwork. Bark. That's not quite good. Teamwork.
No, what is
Perk.
Work.
Perk means it's percolating, it's boiling. Percolating. Perk is that's an unusual word. It means something is happening.
Sophia, I think that it says word.
Work. What other words rhyme with teamwork? Perk. So you can Burke, Kirk, Dirk, Dark, Work, Dark.
Clerk,
Sorry?
clerk,
Dirk? I'm not sure that that's...
clerk, like the ones that are in charge of the buildings. The clerk, C-L-E-R-K.
Oh, clerk. That's a great one, Lula. Clerk. Work, clerk. That's excellent. Okay. Work, teamwork, perk, dark, clerk. Let's start another word that we might use in the poem. Let's say machine. What rhymes with machine? Machine.
Mimi.
Mimi. Okay. Machine, Mimi, machine.
Engine.
Engine. Very good. Lula, you're hot. Engine. Oops.
And also the fin of a dolphin, for example, dolphin fin.
Machine, dolphin. This is a much easier word to rhyme with. Dolphin, machine, engine, dolphin, machine.
Lean.
Lean. Excellent. Who said that? Machine. A lean or mean machine.
I say that.
Okay. Lean or mean machine.
And for teamwork, we could use port, like the ships go into a port.
Teamwork, port. Port. Teamwork. Fork. Work, fork. Pork. Teamwork, fork. Stork, circ. Work. Turk, tark, torque. Torque, work. Of course, sort of. Okay. Can you think of another word, guys, besides teamwork and machine that relates to what we're building? Then we're going to write a couple of lines of a poem that says something to the effect, teamwork is important.
Park?
Park, work, park. Okay. Park. That's good. Who said that? Who said park?
Montserrat.
Montserrat. Very good. Nice one. That's a great one. Okay. Our main problem and mission is to do important things, you need a team. But some people don't like to work on teams. So our mission is to design a machine that demonstrates teamwork.
Lean?
Lean. We have lean here.
Lean with F. Lean is a name of it's a movie.
It's a movie.
Like the reign of hamburgers.
Machine, rain, hamburgers. Okay.
No, hamburgers, no.
Okay.
Lean.
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 Lean, B-L?
Lean with F.
L-E-A-N, that?
Yes.
Lean, I've never heard that word before.
It's a name.
Okay, oh, it's a name.
Yep.
Okay.
I
How about this, serene? Serene means peaceful. Machine, serene.
Alfredo is not here.
Oh, what happened to Alfredo?
I don't know.
Oh, well, maybe he'll come back. Okay, well, we have a couple of words here that rhyme. Let's see if we can make a poem out of this. So, what if we say, well, let's start with some people. Okay, we'll start with our problem mission to do something cool. Left justify this. To do something cool. Cool. You need teamwork. Okay, how about if can we change this to build something cool? How about that?
Yes.
To build something cool, you need teamwork, all right? Let's see if we can find words that rhyme with cool. To build something cool, what are words that rhyme with cool?
Fool.
Fool. Don't be a fool.
Fool.
Don't be a fool. Fool rhymes with cool, right?
Yes. And pool.
And pool. Don't be a fool in a deep pool. All right. Okay. How about we say something that now that rhymes with work, teamwork. To build something cool, you need teamwork. Don't be a fool in a deep pool. Dark. Teamwork, clerk, port, fork. Can you think of something that rhymes with teamwork? So we have pool and cool and pool. What if we do something like,
I have an idea.
sure.
A fork is made with a machine, and that machine needs many people to work or something like that.
Okay. So make a fork. Make a fork. Okay. Fork with something that rhymes with cool. With many people who are cool. What do you think? To build something cool, you need teamwork. Don't be a fool in a deep pool. Make a fork with many people who are cool.
Yeah.
It's a little silly, but it rhymes, and it speaks to teamwork, and it speaks to building something cool. So what if we use this as a challenge for next week? See if you can write 3 or 4 or 5 lines that rhyme, and the alternate lines in your poem should rhyme. The odd lines should end in a word that rhymes or start in a word that rhymes, and the even lines 2 and 4 should also have words that rhyme.
Jan,
Yes.
sorry by disconnecting me.
Oh, okay. That's all right. Sophia, do you like to explain to Alfredo what the mission is for next week? I'll explain this in an email to you.
Yeah, that we need to make a poem.
Or a song. Could be a song too. We could sing this song in the video.
Oh, and you also say that we need to build a machine or a link.
To build a machine. So you could say, to build a machine, you need teamwork. To build a cool machine, you need teamwork. And then pretend you're an engine machine. Maybe we need to think of some more words that rhyme with teamwork. Montserrat, do you like to take a try at explaining to Alfredo how to write a poem?
A poem.
Like we're doing now. What it says, Alfredo's computer was disconnected, so we need to explain to him our strategy for writing the lyrics to a song or a poem.
Jan,
Yep.
I have a rhyme.
Okay, a rhyme. That's the same as a poem. Yes, which is?
Teamwork, homework.
Oh, teamwork and homework is excellent. Excellent. Teamwork and homework. All right. Very good. Teamwork and homework. I love it. Okay. So I'm going to send these slides to you so you can work on number 1, a new module, much like Alfredo did. And secondly, you can document a poem or a rhyme or the lyrics to a song, which we'll use when we present our teamwork machine. Okay?
Yes.
All right. We're going to have a video that I'm sure is going to attract a lot of attention. Not only is it going to work, but it's going to look cool, and we're going to have a explanation in the form of a song or a poem that explains what the machine does. All right, guys. To be continued next week, all right?
Yes.
Okay. So we're getting to
Okay.
practice a lot of skills in this project, from writing poems to drawing graffiti to learning about simple machines. There's a lot going on in this project. Sorry, Lula, you were going to say?
See you next week.
All right.
Bye, kids.
Bye.
Bye,
Thank
Montserrat. You're welcome. Bye, Sophia. Bye, Alfredo. For Alfredo, I love your video. Could you send me your video?
Yes.
Please send it to me. It's a great example.
John, I already sent the email with the agenda and the invitation.
Oh, okay, good. To all the parents, great.
Yeah.
I'll follow up tomorrow with an email for exercises for next week.
Okay.
Okie dokie.
I'm ready for any questions in case you need them, okay? You're gonna rest a little bit?
I'm just going to get a drink of water.
Okay.
What do you think of this exercise of writing a poem? It's kind of
Loved it.
yeah,
Loved it.
I like it too. Not everyone likes to write, but
It's very important because you have to make connections.
exactly, exactly. And this really forces you to think.
Yeah.
Yeah.
And you learn new vocabulary.
And you learn new vocabulary. That's true.
And combinations. And
yeah.
I like it.
It doesn't matter if it's silly or doesn't even make sense. Just the exercise of getting words that rhyme is fun. Okay.
Drink water.
I'll be back in 2 minutes.
Okay.
Bye.
Bye.
Bye, Monse.
Bye.
Make a song, please.
Yes.
Okay. And write it down in a paper so you can read it.
I'm having a glass of milk and a chocolate bar here for dinner. Hey, Miguel. Salvador.
Hi.
Hi, Salvador. Hi, Miguel. All right. Glad you could join.
Hi, kids.
Hi.
So, guys, I heard a little bit earlier. Hi, Brent. I see Brent just joined. I heard a little earlier that Julian was in an accident. Hi, Constanza. Great. I hope he's okay. I don't see Julian online yet. Hi, Brent.
Hi, everybody. Can you hear me?
Yes, loud and clear. Thanks
Perfect.
for joining.
You're welcome.
Let's wait just 1 or 2 more minutes to see if Julian joins. Sophia. Anyone have any interesting stories to tell from the week? Anyone? On a basketball team? Anyone in a sports team or making music? Who on the team plays an instrument? Does anyone play the guitar or the piano?
I do.
Miguel,
Yeah.
what instrument do you play?
The piano.
Piano.
Yep.
What kind of music do you like? What's your favorite song?
I don't know. I actually like most of the type of music, but I don't have any special. So
Cool. Nice. Music is a great way to relax.
yeah.
I like to play the guitar. Well, let's do this. I'm going to show you where I hope we'll all be by the end of the class. And then we'll pass the ball around and we'll see where you are and answer your questions. Does that make sense? Okay.
Yeah.
So, is that Rodrigo just joined? Fantastic. All right. I think we have almost the whole crew here now. So let me share my screen and we're going to go to let me X this, escape this, go to here. All right. So I think I sent this file to you. You should all, by the way, while we're talking, log into, hi Pablo, welcome. You should all log into BIYAAAA. Brent, perhaps you could put this in the chat box. And the password for scratch.mit.edu is Robot Sushi 1 with a capital R and a capital S. So all of your files, your projects should be stored at BIYAAAA. Password Robot Sushi 1, capital R, capital S. And it's at the URL scratch.mit.edu. Okay, let me open up the chat box just so I can follow if anyone's. Brent, I'll trust you'll answer any chat questions.
Sure.
Great. Okay, so one of the things we want to talk about today is the concept of modular construction when we're programming. In fact, when we're building, when we're drawing, and no matter what we're doing, if we're doing something complicated, we want to try to break it down into its simplest parts, which is sometimes called modular construction. In fact, let me take a slight detour and just talk a little bit about the advantages of modular construction. So modular construction has four advantages, basically. It allows you to build really quickly. It allows you to edit or change your solutions easily. Modular construction usually results in a machine that's more reliable because you're reusing modules that have proven to work. You're not building something brand new. And modular construction generally is simpler. It's more simple. And let me show you an example. So here's a robot that when you put a quarter in its mouth, it shakes its head yes or no. So you want to ask the robot a question, you put a quarter in his mouth, feed him a quarter, and the robot will shake yes or no in answer to your question. Now, you might look at this project and you say, wow, I could never build that. That's really complicated. Here's what the engine looks like. But if you break this down, it's really made from a number of very simple modules. So this is one of the modules in this engine room that makes a puppet respond to a quarter and shake its head yes or no. And it has a gear train, which is this module. Very simple to build this. But when you embed that module in a more complicated machine, then it does one function of many functions that machine has to do. Then there's a coin sensor module. There's a module that makes the coin sensor go up and down. So this makes its head shake yes, shake yes. And then it has another module, gear train, that drives this up-down module. So that's module 4. And then it has a modified chassis module, which is controlled by this gear train. So it has 5 modules, and you put all those modules together, you get something that looks and works in a really complicated way, but it's basically made from a whole bunch of really, really simple modules. Easy to edit, easy to replace, easy to explain. Not only does modular construction work when you're building robots, but it works for a lot of other things. When you're making a puppet, a sculpture, for example, when we make characters, we make the hands, that's one module. Then we make the hair, that's another module. Then we make the eyes, the nose, the neck. And then when we put all of those modules together, when we integrate them, we get the finished puppet. So the puppet looks quite cool, but if you take it part by part, the puppet looks fairly complicated, but if you take it part by part, it's just made of very, very simple parts. Understand so far? Okay, I'll assume that's a yes. Modular construction is also used in music. Who can explain what the concept of modular construction in music might be? Anyone, any musician on the team that can think of how modular construction could apply to composing a song?
John?
Yes, who's this?
Pablo.
Pablo, okay. How do you use modular construction when writing a song?
I think it's like the same of the puppet. When you do a song, you do it by parts.
Yes.
One part is a note.
Yep.
And another part is another note, and it goes like the notes are like the pieces.
Right.
And they form all a song.
Great. Okay, that's an excellent explanation, Pablo. So for example, here could be a series of notes, and they sound really well together. You could take this module, or this, what in music is called a riff, and you can just copy it, and you can play it a second time. Right? So that's an example of modular construction, that when you get a complicated song, you break it down into parts, and you can use those, you can reuse those parts. In programming, what we're going to focus on, in fact, in this class today, is 2 ways to make your rocket move. Both work, and both work quite well, actually, but one looks a lot simpler than the other. And we're going to show you how to make your rocket respond to keystrokes by using this approach, which has several advantages and some disadvantages, and also by using this approach, which is less modular, but it has some other advantages. But at any rate, we want to start by simplifying your code in modules, and then gradually, once we learn the simple approach, we'll add complexities to it that might bring more power to the program. But let's start with simple modular construction. So what if we do this, guys? Just for 5 minutes, let's add a page in your lab book before we do Scratch that documents the importance of modular construction. We want to have at the end of your year with Build It Yourself a lab book that you could, where you can explain all the important tricks you've learned at Build It Yourself, maybe when you're applying to school or applying to a job. You want to have a lab book that that documents useful building skills. And modular construction is one of the most useful building skills ever. While you're documenting this, I'm going to talk about a couple of examples of how modular construction is used to make some really amazing things happen. Brent, perhaps you could Google building a skyscraper in China in 43 days. So there's a story in China. Generally, to build a skyscraper in the United States takes years. In China, they have the art of modular construction down so well that they could build a skyscraper, I think it was 49 days. In 49 days, they built a skyscraper.
Less. It says 19 days, 19 what I found.
Okay. Brent, maybe if you have a Google of that, does it look interesting?
Looking at the picture of the skyscraper is definitely interesting. I'm going to put the link in the chat box.
Okay, well,
or I can share.
Why don't you share your screen, Brent?
Definitely.
So this is a really famous example of how important modular construction can be to building something really complicated very, very quickly. So this skyscraper is made up of many modules that were built off-site, and then they just trucked those modules in, and they stacked them on top of each other like Lego blocks, and in 19 days, they had this whole skyscraper constructed. That's an amazing story. I understand Volkswagen is pioneering the idea of modular construction, and the Volkswagen cars of the future are going to be a lot cheaper and a lot more reliable because they have a manufacturing process that enables Volkswagen to build really complicated cars very, very quickly and very, very cheaply using a modular construction technique that they've pioneered. Volkswagen has a famous production plant where they do that. Oh, okay, cool. The point, guys, is that modular construction is a very, very useful strategy for business that is fundamental to the way big companies build complicated products like skyscrapers or cars or Apple computers. Okay, thank you, Brent. Perfect. If you can stop, I'm going to share my screen again so we can I'll give you a couple more minutes on this, and then I'll send everybody a PowerPoint, an email with exercises and links that you can complete anything that you haven't completed in this hour. So we want to add this page to your lab book, modular construction title, and then 4 advantages of modular construction. Build quickly, edit quickly, make reliable, and simplify. Okay, everyone got that? Don't worry if you haven't, we will,
I need time.
okay. Rodrigo, I'll send you the PowerPoint so you can do it on your own time, all right?
Thank you.
We won't hold everyone up. Okay, so let's go back to this, and we want to get everyone to this position. So right now, what we have is one rocket. When I hit the arrow key or hold the arrow key down, it goes up, left, down, or right, okay? And that's done by these blocks of code, right? It's really easy to make this. I'll show you this once more. You know how to do this. You know how to point in direction, and then move, and then next costume, go to looks, next costume. Where is the next costume here? Looks, next costume. Okay, and then a quick way of working is if you right-click right here. Hold on a second. If you right-click, where are we? Right. Oh, there we go. Right-click here, you can duplicate, and then that duplicates this. So you have to click a little bit off of the block. Right-click here, duplicate. And then you have 4 of them, and then all you have to do is go in and change each one of these to make it go right, left, or up or down, right? Excuse me, I made this wrong. Sorry, guys. Let me start it again. Not when I hit the green flag, it's when I click this bar. Okay. When I click the up arrow key, and then I can right click here, duplicate. Oops. I want to right click a little bit off, and then I get the whole block of code. So that's a trick for when you have modules, you can duplicate that module and make it happen very, very quickly. Okay? So that's the first exercise. Let's see if we can get this code embedded under your sprite that has the rockets. So your whole sprite, let's start with that. You should have your rocket embedded in Scratch. Here's the customs. In fact, you should have 2 rockets, one with fire and one without fire. Then you should have scripts that look like these 4. Okay? Okay. Has everyone got that? Or knows how to do that? You can work on it on your own time, but everyone gets this, right?
Yes.
Okay, good. Anyone need help on making this work? Okay. So the next part is you want to import your planets. I think last week we all covered how to import your planets. And then we want to detect when the rocket hits the planet. And this is the code that detects when the rocket hits the planet. So for example, if I make this rocket go up here and hit the planet, oh, I have to, sorry guys, I need to hit the go flag. So I'm gonna make,
John,
yes?
I do it, but in another way.
Okay, we'll have a look at that. So here's how we we'll have a look at yours after we get everyone up to here. Okay. This was who was it that did it another way? Rodrigo or Pablo?
No, Pablo.
Pablo. Okay, good. So if we go down here, okay. So this is the code that we want to create to make your rocket ship land on a planet. Now, if you do this, your planet has to have these costumes. So let's go to a planet. I've got this. Here's the planet. Oh, excuse me. The planet scenes are backgrounds, not planets. So the planet just has the planets for costumes. All right, but your background, this is where you're gonna upload the scenes for your planet. And we'll show you how to write the code for that later on. But by the end of the class, you should have one rocket ship loaded with 2 costumes, one with fire, one without fire. You should have this code done. This code is a little bit more complicated. Who would like to explain how this code works?
Me.
Okay, go ahead, Pablo. Was that
Rodrigo.
you or Rodrigo? Was that you, Rodrigo, that said you could
Yes.
explain? Okay, go ahead. Explain how this block of code here works.
Forever,
Yep.
if the rocket is touching the planet,
Yep.
then it will play sound.
Yep.
A sound.
And then it says wait until.
Key space not pressed.
Okay.
Broadcast DIY.
Yep. And that tells the background to change from the planet scene or the space scene to a planet scene. That's why we say broadcast BIY. We want to call up the planet BIY. Mm-hmm.
And it will point in direction 0.
Yep, which is
and it will
up.
go to a coordinates.
And then it goes to the top of the screen. This is X, Y, X is 1 here, and Y is that's about this position right here. And then what's the next one? Glide.
Glide in 2 seconds. Glide to another position.
Okay.
Minus.
Great. Great. So let's watch what happens here if we make this planet, this rocket, go down here. See how it glides down to the planet? That all happens in this code here. So we check, whoops, sorry. We check if it's, we do a forever loop to check if it's touching planet JG, and then if it's not touching that planet, then we check if it's touching planet Popeye. We have 2 planets, planet JG and planet Popeye. Both tests are exactly the same. They're just testing different planets, and then they're broadcasting a different message so that the background can change. All right?
John?
Yes. Who's this?
Sophia.
Sophia. Okay, Sophia.
Is that I'm trying to enter to Scratch, but I tried like 10 times and I can't.
You can't enter Scratch?
No.
Okay. So let's, I'll stop sharing my screen. Guys, do you think you can get this?
John?
Yes.
Hold on a second. Yes?
I don't do the code that you do for enter to the planet. I do
Yeah,
another code and
it works.
work.
Okay, cool. We'll show you in a while. Let's get Sophia up to speed because she can't do anything unless we can launch PowerPoint, or excuse me, launch Scratch. So, Sophia, can you share your screen and let's see if we can troubleshoot why you can't reach the website, MIT Scratch. Okay, scratch.mit.edu.
I think you have the password and username backwards.
Yeah, at the very top where it says nombre de usarlo, put BIYAAAA. BIY for build it yourself, and 4 A's, AAAA. Thank you, Brent. And then down here, put Robot Sushi 1. It's in the chat box. Robot Sushi 1 with a capital R and a capital S. Okay. Whoops. You have to type in HALI. Oh, I'm sorry. I was asking you to check there so that it's not a robot. HALI, type that in where it says contraseña.
H.
Yep, HALI, capital H, capital A, capital L, capital I. It's just asking you to type that picture in the white box. And that's one way of stopping robots from creating havoc on the Scratch website.
HALI.
LI. Okay, right here. So Calle, you can do this. Type in Calle, C-A-L-L-E, street, Calle. Can you type in Calle? Oh, I think we might be entering in the wrong box there. You have to enter in below where it says introduzca el texto. Yep. Yep. Thank you, Brett. That might be the problem. Whoops, no, not Robot Sushi here. You want to type in Calle, C-A-L-L-E.
L.
Yep, L-L-E, right. Okay, let's see if that works. Oh, it wants you to type in both words, Calle and then Moto. Wow, it's really making you work hard here. See what Brent has typed on the side, Sophia?
Adiós.
All right, success. Are you signed in? Oh, no, now you have to sign in BIYAAA, Robot Sushi 1. BIYA, just select that, right, select the BIY right below. Select the BI, yep, okay, and then this is capital R, Robot, capital S for sushi, 1.
This is popping up just because so many failed attempts, they need this to happen.
Oh, well.
Before you type anything in, let me type on the screen what to put where.
Thank you, Brent.
Every time the capture isn't accurate, it erases the password. So I think you're leaving a field blank at times. John, does that look accurate?
I have no idea what it's saying. It's so hard to read. It looks right. I can't read the second word very easily. Yeah, but I think you're right, Munha. Wow, what a pain in the neck this is, huh, Brent?
It is, but it's how we get to enjoy Scratch
That's
because they
right.
protect it from the vile villains.
That's right. That's a good way of thinking, Brent. Thank you for mentioning the upside.
Success.
All right, you're in. Okay, so at the very top, you want to go to My Stuff. So take that window at the top right of your screen and move it down, and you want to go to My Stuff. Yep, go under BIYAAA, there's a little arrow. Yep, press that arrow up higher, right there. And then My Stuff, Mis Cosas. Yep. And then find your project. Sophia, good. Okay. Great. All right, let's help Sophia get up to where you all are. So right, look inside. Ves dentro. Okay, we can click on the cat and just delete that. Right click on the cat and then delete. Okay, now you have that. Okay, now let's go to Programas. Click on Programas, yeah. Okay, and did you see that code that I had written on the screen?
Yes.
Do you think you can repeat that code? No, the top one, go to Eventos, at the very top, yep. And then Al Presado, no, not that, but the other one, right below it, that one right there, yep. And then instead of espacio, put up arrow. Espacio, put up arrow. Click on that arrow. Click on the black arrow. Up arrow, okay. Who can tell Sophia the next block of code that she has to write to make the rocket go up? Anyone want to help Sophia?
I think it's forever.
No, hold on a second. Let me, can you try to make two windows here? If you stop sharing your screen, I'm going to grab my screen. This is what you want. This block of code here. So the script for the rocket ship, should make sure you've selected the rocket ship and then go to scripts and write these. Actually, you want to write this block of code too. This block of code will initialize your rocket. Will start your rocket at the right position. And then these blocks of code make it move. So, Sophia, I'm going to send you a link to this project so you can study it, and then you're in good shape here. All you have to do is now add this code. Okay, so don't worry if you get stuck, Sophia. We'll send you an email that will try to explain how to get your project up to this point. So.
Okay.
Great. Was it you, Pablo, that said you had a different way of doing it? Pablo, you said you had a really unusual solution for making your rocket move? Your mic is muted, I think, Pablo. Who was it that said they had a cool way of making the rocket move. Let's see how you did it. All right. So maybe your microphone is stuck. Let's go around the room, and we'll let everyone share their screen so we can see where you all are. And let's critique everyone's work. So I'm going to stop sharing. And Ari, can you take
Okay.
Share your screen and show us where you are?
Yeah.
Rodrigo.
Yes. I can charge my planet to scratch.
Okay, Rodrigo, we're going to go around the room. We'll share. You'll get a chance to share your screen shortly. Let's follow what Ari is doing first.
Okay. First.
You have your rocket. Show us. Okay.
Yes.
So, oh, look at this. Good. Okay, you fantastic. Whoa, guys, look at this.
Wait a moment. I haven't.
Very good, Ari. So Ari's got a very clever way of making the rocket move, and it's a little more sophisticated. What is your next step, Ari?
I am making this so
All right.
when
Okay,
you touch
good.
a planet.
Yeah.
Oh, oops. Wait a
Start from the
moment.
beginning. Yeah. Okay. You have one planet that's already working.
Yeah, I need to do this first.
All right.
So when you do this,
Yeah.
fall down.
Okay, cool. You got it. Beautiful. Beautiful. Can you show us your backgrounds? Let's see the text on your background. So guys, follow what Ari has done here. It's really excellent. How did you get this far, Ari? Did you were you able to study the file that I sent you?
No.
You just did it on your own?
Yes.
Cool. Okay, you're a good Scratch programmer then.
Thanks.
Very, very good. Okay. So, Ari, I could challenge you to, when the rocket hits the top of the screen, then go back to the space scene.
Yes, I'm going to do that.
Question
next.
on this planet, then you want to hit the up arrow key, and you want to detect when your rocket hits the top of the screen. So press the up arrow right now. Keep going. Keep going. It's right there. You can detect when your rocket is at the top of the screen, and then you want to send a message called space. And then when your background, you want to say detect when I receive space, switch to the space background. Does that make sense?
Yes.
So you can go from space to planet and back to space.
Yes.
And then you want to do the same thing for all of your planets. Excellent, Ari. Guys, if you follow what Ari's doing, he's on the right track. Okay, so who's next to Ari? Who wants to go next?
I can charge my planets.
Okay, Rodrigo, let's go.
I am doing the program, but I can charge the planets to Scratch.
Okay. Share your screen, Rodrigo.
I have another way to make the rocket
move. Okay.
This one.
Generally, there's always more than one way to make something happen. Whoa, that looks very, very complicated. And does it work?
I have already used it and it works.
Okay, but you don't have your rocket imported into your Scratch project.
No.
Okay, so let's get your rocket in there first.
Yes.
Rodrigo, this is very, very complicated what you're doing. It's very creative and cool, but let's go one step at a time, all right?
Okay.
Let's import your rocket first. Whoops, what happened here? Okay, so let's go to costumes or disfraces at the very top. Disfraces, costumes, right there. Okay, and let's hit
Look.
the folder. Yep,
I can't.
click the folder, and it doesn't
I
open.
can't. No. Or here? No, I can't.
Okay. Wow. Huh. Not able to import anything. That's
No.
strange. You know what I'd suggest
What?
to start? Let's, I don't know, Brent, you might try relaunching Scratch.
I already did that.
You already
And
did
it
that,
didn't work.
and it still doesn't work.
I'm thinking it might be an issue with the web browser itself,
Ooh.
because all browsers are slightly different.
Well, it doesn't have Flash maybe installed.
Yeah, or some features could even be limited.
Yeah. You have two browsers down there. You have Chrome and you have
No, Firefox.
Firefox. Okay. And you have Safari. Let's try your other
Yeah.
browser. Brent, that's a great suggestion.
What's this?
Let's try another browser. Firefox. So Rodrigo, try to launch another browser and then go to this to the Scratch site and see if that one works. All right, we'll come back to you.
Okay.
Okay, I think Brent is onto something right there. Your browser doesn't have Flash installed. Okay, let's try someone else. Who hasn't shared their screen in a while? Constanza or Pablo, Norman, Miguel? Who would like to show us where they are?
Can I pass, John?
Okay, sure. Are you making progress, Miguel? Or
No,
Pablo?
I'm Pablo.
Oh, Pablo. Okay. Do you want to show or do you want to pass?
Can I show?
Sure. Okay. Go ahead. So you have to stop sharing your screen, Rodrigo. Okay.
I thought that I could share my screen at the same time that Pablo.
Oh no, only one person can share.
Okay.
Rodrigo, try to launch another browser. I see you have two browsers installed there. Okay, Pablo, let's see what you got.
Okay. Here.
Oh, whoa. Sweet.
Wait.
So guys, have a look at what Pablo's doing because I think he's got it pretty far along.
And then
Okay. If you hit the up arrow, does your rocket? Okay. Oh, you've got it. Can you show us? Oh, wow. Look at this. And you've got rotational control. Wow.
wait, I have. Oh, I don't see that.
Change is not saved yet.
It says that it's not saved. I'm going.
So save
There
it.
is.
All right. Yep. Okay, good. Okay. Pablo, can you show everyone your code for making the rocket move?
Here. Oh, again? No.
No. Show the code and explain how you get your rocket to move. Can you point to the code? You have to shrink your screen a little bit so we can see it. Pablo, can you show us where the code is that makes your rocket go up or down, right or left based on an arrow key? Well, I think we must have lost Pablo. Okay. I think we lost Pablo. I'm going to see if I can grab the screen back. Okay. Norman or Salvador, you want to take a cut at showing us where you are? Salvador, how are you doing? Would you like to share your screen and show us where you are?
I had to restart my whole project because I think my project got erased.
Oh.
So I just started.
Oh, too bad. So
yeah.
Oh, too bad. But you still have your PowerPoint, right, with all your rockets?
No, that's what got erased. I only have my rocket.
Oh, wow. Okay. But you know what to do, right?
Yeah, I am. Right.
Okay, so that happens to the best of us, Salvador.
Yeah.
Computers aren't always our friends.
Yeah.
Too bad. Okay, Norman, would you like to share your screen?
I'm getting my rockets to scratch because I think my project got erased. So I'm.
Your project got erased from scratch?
Yeah.
Okay. So you're recreating it?
Yeah, exactly.
Okay. Do you understand what you need to do? Did you see the example that I sent you? Norman, do you know what you have to do?
I haven't checked it, but I'm checking it right now.
Okay. So I sent you last week a link to the project that I just showed you. And it should show you exactly the code you need to create. So
okay.
I would start by just replicating that code.
Okay.
Okay. All right. Constanza, would you like to share your screen?
Yes.
Let's see where you are.
John?
Yes, Rodrigo.
Now it works.
Okay, Brent. Thank Brent for that. All right, Rodrigo, let's see what Constanza has done here. Wow, I think Constanza is going good.
I'm the moon is too big.
Okay. Set size too. Yep. Good. You know exactly what to do, Constanza.
Thanks.
Do you have your rocket moving?
Mm-hmm.
Okay, show us when you hit the arrow keys. Oh, look at that. Very cool. I love it. And I like your background a lot.
Sorry, John.
Thanks.
John, sorry.
Yes, no problem. Is this Pablo?
I disconnected yes, I disconnected. I have a bad connection.
Okay, Pablo, we'll share your screen in just a second. Let's have a quick look at what Constanza has here.
Yes, cool.
We'll come back to you in just a second. So the next thing you need to do is write code in here that detects when you hit a planet.
Mm-hmm.
You have 3 beautiful planets here: the moon, the star, and a planet. Very, very cool. And can you go to the costumes where your backgrounds are? Your artwork is magnificent.
Thanks.
Can you go to your backgrounds? Yeah. Go to costumes. Wow. Okay. Cool. Very, very cool. I love it. I just love it. Okay. So let's go back to your rocket and look at the code for your rocket. No, not the, the actual code. Good. Okay. So the next block of code you need to write, move when 11 times. Okay, down arrow. Oh wow, you hit the space bar. That's very clever. When you hit the space bar, you like go really fast, right?
Mm-hmm.
Okay, that's cool. That's a great idea. All right, you need to write this code. I'm gonna stop sharing my screen, and I'm gonna share my screen, and I'll show you the code that you have to write to detect a planet. It's this code right here. So guys, if you're working on detecting when your rocket ship hits the planet, this is the code that you have to write. This block of code that I'm moving right here. I'll send this, I'm going to send a link to this tomorrow morning, so you'll all be able to work on this over the week. But all you have to do is replicate this code. And in the process of rebuilding this code, you should understand how it works. If not, next week, we'll help you. But the first, just replicate this code, repeat this code, duplicate this code. And this code will allow you to steer the rocket, and this code will tell you when you're touching one of your planet sprites and send a message to the background to change backgrounds, and then point the rocket so it's pointing up, and then it glides from the top of the screen down to land on the planet. So let me just start and show you exactly how this works. So if I hit the green flag here, excuse me, I'm gonna stop. Watch this, guys. Just stop. Okay, so here's this rocket sprite. Notice when I move the arrow key, the rocket moves, right? And then when I go down to here, when it hits the planet, changes screen, makes a sound, and the rocket goes down to the planet. Okay? And then the next challenge, guys, is going to be we're going to have the alien ask a question. And after you answer the question, then we're going to make the rocket ship go to the top of the screen. When it goes to the top of the screen, we've got to detect that and go back to the space scene. That's the strategy to get all of this working. So, guys, we have to remember to save every time. Save, so we don't lose our work. All right, we have a few more minutes. Let's go back to you, Pablo. At 8 o'clock, we're going to have to stop because I think we have some other people coming on.
Okay.
Did everyone get a chance to share their screen? Or if they didn't, I think you were Salvador. You had to start over again, and same with you, Miguel. Okay, Pablo, can you share your screen? Oh, let me stop sharing mine. Okay, Pablo.
I have it here.
Okay, it's coming up. Wow, look at this. Okay. Nice. Whoa. Lands beautifully. Stop it, and let's start it from the very beginning just to see when you start it up.
Okay.
Hit the red stop button at the top of the screen, and then hit the green go flag. Yep. Now hit the green go flag. Okay, so we're gonna have to initialize all your sprites so they come at the right time. So they all start at the same point.
Here.
Okay. Wow, I like the way you control your rocket. Rotational control. That's very sophisticated. Oh, beautiful. Okay, so guys, we can learn a lot from what Pablo has done.
And here is the planet, but more little.
Yes, it's very real.
Away.
It's very, very real.
And then.
Beautiful. Okay, you're well along, Pablo.
And I'm also doing the alien.
You're making the alien now. Good. That's the next step. So your alien comes up on a planet to ask a question. Okay.
Then I showed you the alien.
Yeah. Show us. Show us in PowerPoint.
Look.
Okay. All right.
It's going to be an animation.
Oh, all right. You know how to make animations now. Good. That's certainly an odd-looking character, an odd-looking critter. So he classifies as alien by my measure. Very nice, Pablo. I can tell you know what you're doing.
Thank you.
All right. So Rodrigo, you should be able to import your rocket now, right?
Yes, but first I like to do the program.
Oh, but you need your
Well,
graphics. You need
I
your
already imported the rocket, but only the rocket.
the rocket. Okay. Rodrigo, I'm going to send everyone a link to the project. And so by looking at that project, you should be able to understand all the code you need to write to control your background, the rocket, and the planet.
Okay.
So follow that code before you start writing. Have a look at this master code. And you don't need to follow it if you have better ways of doing things. That's great. But if you're just starting from scratch and you're starting as a beginner, you can learn a lot from that code. Okay, guys, to be continued next week.
But then,
I saw great things.
All right, Rodrigo, yep.
can I use a variable?
Of course, but Rodrigo, I'd suggest you start walking before you start running. Walk before you run. We can use variables to control the score and other things, but let's just get your rocket ship working first. Before
I
we
always tell him that.
Before you run, let's make sure we can walk. All right. I like your ambition, Rodrigo, but let's get the basics down first, and then you'll be able to run much better. Okay. I think we're coming along. We're getting everyone pretty much close to the same point.
Yes, I'm very happy to listen and to see what they're doing.
Okay. And patience is going to be rewarded, guys. Stick with it.
Okay.
Okay, Lula, thank you for joining.
So,
bye, everyone.
Thank you.
You're welcome, Salvador.
Bye, everybody.
See you next
Thanks,
week.
Brent.
Bye.
Yes, bye next week.
Bye.
Bye.
So when you have the time, check the program and check everything.
Okay. All right. Great.
So that
Thank you for setting everything up.
we just hope you will have fun and don't get so tired.
Oh, I'm sure I'll have fun. I'm eager to see what you all are doing. I have a feeling there's some magical things happening there.
John, only one thing, it's important. What is more or less your, you will need a space with computers to run other classes from other.
Yeah, I'll bring a laptop.
Okay.
And I can work from that laptop.
Okay, perfect.
Yeah.
And the other thing is your sleeping hour. You sleep at 9 or 10?
Oh, anytime, Lula. I can adjust easily to your schedule. Don't worry about it.
No, we worry about you. Because we Mexicans are too pachangueros.
What's that mean?
Pachangueros, lots of fiestas.
Oh, lots of fiestas. Okay, me gusta fiestas.
Okay. Don't forget your hat, please.
Okay, I'll bring the brainstorm hat. Sure.
Please, 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 because you're going to notice that in the posters, you're wearing the brainstorm hat that
Okay.
the picture of the poster is a picture they took you in 2008 when you came here.
Oh, wow. Okay. All right, great.
So I don't know if you have that hat, but I have seen one very similar to
Yeah, it's a new one, but it's similar, right?
that. Okay, so please don't forget that.
Okay.
It's part of you.
All right, Lula.
Okay.
Thank you. All right.
Take
Thanks
care.
for
Bye,
coming, Lula.
Brent.
Thanks for your time. See you soon.
Bye, Lula.
See. Bye.
Hey, Brent, thanks for joining. Let me send an invite to our crew.
All right, sounds great. I can stay on till 8:30. I'm by the computer.
Good. Yeah, don't worry, Brent. I know you have other things and Anna's, so I can fill you in tomorrow.
Okay.
Okay, I think this is the whole crew. Oh, I forgot Jessica. Default email, Jessica. Okay. Well, that wasn't great, but oh, let me stop sharing my stop recording.